Karthik, Brian, and I took operating systems last quarter where we added components to OS161, a toy operating system. Since OS161 didn't have any network support, we thought that it would be an interesting problem to try to add real-life network support to OS161.
Since we decided to write real network support, we needed packets to be formatted for TCP/IP. But we quickly decided that writing the TCP/IP stack would be too complicated, so let phub turn an OS161 formatted packet to a TCP packet with the same payload. Let's talk about the OS161 header. The first 4 fields are mandated by the virtual machine. The first is a framing word to ensure this is a well-formatted packet. The from address is the OS161 of the sending OS. The to address was supposed to be another OS161 number because the fake network support from the virtual machine was intended to pass messages between OS161s. However, we just define a special address to indicate the rest of the internet. Finally, the packet length is just the length of the packet. The 2 fields we added were the connection num and action ID. The connection number is essentially a port. It identifies a specific connection so that an OS can route incoming packets to the appropriate connection. This allows multiple processes to listen or send on the same port as well. The action ID tells the phub or OS how to interpret the payload of the packet and what higher level handler to use. So now we can step back and look at those 4 major actions. Connect establishes a connection to a host and port through the phub. Send similarly just tells the phub to send bytes to a remote host. Receive is more interesting. We have the phub automatically forwarding incoming packets to the OS, so receive takes bytes directly out of the OS buffer for that connection. Close is what you'd expect, just tells the phub to close the connection to the remote. Alright, now that we've seen an overview of the design, let's see it in action. First, we wrote a user program called get that does a simple get request to a host on a specific port, or defaults to port 80. So let's do a get request to google.com. Alright, we can see that it returns the HTTP headers as well as the HTML for google.com. Now that we can connect to the internet and successfully send and receive data, let's talk about Telnet. Telnet was often used as an insecure remote shell before SSH. In a nutshell, no pun intended, Telnet is really simple. It essentially forwards anything you type over the network and prints out anything that it receives. Our implementation connects to the specified host and port, but this time we actually fork a child process. The parent process sends any characters you type, and the child process prints any characters that come back. Alright, so we can see this in action with a simple Telnet server that just echoes any characters you type back to you. So we have the Telnet server running on the right-hand side, and now we'll connect to it on port 51234 from OS161. Alright, so you can see that as we type characters, they get reflected back, and those get printed on the screen. We can also get more fancy. Let's try using Telnet for useful things over the network. So we can Telnet a time server. And you can see that it responded with the current time. Alright, so now we really want to get fancy. Alright, let's play a 1980s style game through Telnet. Alright, so that was a cool little demo. That's our basic implementation of Telnet. We could improve our implementation of Telnet to support some of the more advanced features. We could also build a Telnet server so that you could Telnet into OS161 and control it remotely. There's a lot to work with here, especially with network stuff and HTTP and TCP. So, thanks for watching. Go Dogs.